Assalamualaikum and good morning to everyone. So welcome to the last chapter, which is chapter 7, Thermochemistry. So I am the Siti Noor Hidayah Mustapha. So I will present to you on this particular chapter. So in thermochemistry, you will have three subsections, which is concept of enthalpy, you will learn on calorimetry, and the last part you will learn on Hess's law. Alright, without further ado, let's understand what is thermochemistry. So when we talk about thermochemistry, it's basically you will focus on heat. So how energy in terms of heat will reflect to your system when you have a chemical reaction. So for example, if you can see from this particular picture, so you have an ice cream and also a cup of coffee. So if you can see, if you expose the ice cream and also the coffee at atmosphere, okay, for about 10 minutes, you can see the difference from the 0 minutes and after the 10 minutes. So at the first, ice cream will be cool, and then after 10 minutes, ice cream will be melt. What happened to the coffee? Coffee at 0 minute or at the first place, when you put on your table, it will be hot. Alright, so after 10 minutes, so after a period of time, which is like example 10 minutes, your coffee from hot will turn to warm or turn to room temperatures. So how this can possibly happen? So this is actually related to what we call thermochemistry, and actually it's related to the heat transfer. Okay, at the end it will behave different from previous, so different from 0 minutes. So the first thing, when you want to analyze and understand the whole system, you have to understand terms. So this is the important terms in thermochemistry. So the first one is heat. When we talk about heat, heat is actually energy transferred between two bodies of different temperatures. So meaning that you have to really understand, when we talk about heat, heat is different with temperature. Now we are talking about heat. Heat is a type of energy. Alright, so energy that transferred between two bodies when it have different temperatures. That is heat. Alright, so system, when we talk about system, system is any specific part of the universe. Anything you can when you want to study about any system, then you have to choose your system. So system can be anything. Alright, so the last one is surroundings. Surroundings means everything that lies outside the system. Okay, so let's see example of this ice cream. Alright, so from this ice cream, you can see that ice cream have temperature, let's say it is -1 degree C. Alright, so this is the temperature, and the surface of the ice cream will be this will be your system, this will be your boundary, and this will be your surrounding. Alright, so means that system can be anything, right? So you have chosen, since you want to know about this ice cream, so this particular ice cream surfaces will be your, inside that will be your system, and then outside that will be your surrounding. And of course, surrounding will be the air, or at the room temperature, which is 24 degrees C, for example. And when you have a different temperature, you have 24 surrounding, and the ice cream you have -1 degree C. So when you have two different temperature, you will have energy, or you will have heat transfer, what we call as heat. Right? So it reflects terms that you have learned over here. So heat, system, and surroundings. Thermochemistry, you want to learn on heat. So you know heat is a type of energy. So energy is actually, we can define energy is the ability to do work. The unit of energy is joule. So please remember joule, and 1 joule is equal to 1 kilogram meter squared over second squared. Okay, so how you want to know the conversion? So this is what we call conversion. So conversion is actually will always give in your appendix during your examination, or else when you work, alright, so always refer unit conversion table to know the conversion. But just bear in mind, when we talk about energy unit must be joule, or the older unit of energy is calorie. Alright, so you know that if you take food, for example, you eat bread, so bread will have a certain calorie, right? So, or you eat rice, rice will have a certain calorie. So that calorie means you eat a certain energy. You can have a certain energy from your rice. So energy also can be converted, calorie also can be converted to joule. Alright, so again, this unit conversion you just can see from unit conversion table. Chemical reaction means you have A plus B is equal to C. This is what we call chemical reaction. So whatever A and B equal to C, which is your A and B can be understand as this is reactant, this is product. Alright, so thermochemistry means a study of heat in terms of energy, in terms of heat in the chemical reaction. So when you have reactant and you have product, so means that is will be a chemical reaction. So actually, two types of chemical reaction will be exothermic and endothermic. Okay, so H for exothermic reaction, the enthalpy will be negative. Alright, so or the and heat will be released. So you can see from here, exothermic reaction have enthalpy negative value, which means enthalpy of products is lower than enthalpy of reactants. Okay, so heat is released from the system to the surroundings. Okay, and then for example is combustion and neutralization. So this is three key points that you have to remember. The first one, when we talk about exothermic, delta H must be negative, and then the heat must be released. When you talk about heat negative, meaning enthalpy products is lower than reactant. Okay, so this is the example. So the first one is combustion. You know that when we talk about heat of combustion, meaning that oxygen being added to combustion. Alright, so 2H2 gas plus oxygen gas is equal to liquid water plus heat. So this is example of exothermic reaction, which means the enthalpy of products here is lower than enthalpy of reactants. Or you can understand as heat will be released. Okay. Or the second one is combustion of methane gas. Alright, CH4 gas plus 2 oxygen gas will give combustion will give you carbon dioxide and also water. You know that this phenomenon is a combustion. When combustion will give you exothermic reaction. Exothermic reaction means you will release heat. So that's why reaction of CH4 and oxygen will produce carbon dioxide, water, and also heat. Alright, so example. So you can see this is example of your reaction. A plus B equal to C. You have reactants A and B, and then you have product C. And for example, this is exothermic reaction. So you know that exothermic reaction will give you negative enthalpy value. So what is actually, and you know that negative enthalpy value, it's meaning that enthalpy of product lower than enthalpy of reactants. So how you want to understand this particular statement? So this particular statement is explained by this particular graph. So you can see from here, this is energy profile diagram. So we call it as energy profile diagram. So this diagram specifically for exothermic reaction. So you can see from here, let's say this is particular energy level, right? Okay, so this is x direction will be your pathway, and y direction over here will be your energy level. Alright, okay, so for example, you have a certain energy level over here. You start from here, you have A and B, your reactants have certain energy level. Alright, and then the energy will increase, okay, above the EA or activation energy. So that is when it come to the maximum, or it cross over the EA, so it can produce a product over here. Okay, so meaning that if you can see from here, alright, so this is from the level of the first energy to the maximum level, we call it as activation energy. Okay, so all the things besides the activation energy, so meaning this area will be your delta H. Okay, in this particular case, your delta H value is negative. Why? Okay, so let's say I will redraw so you will understand more. Okay, this is, let's say, enthalpy. This is your profile or pathway. Alright, so this is your energy. Okay, let's say you start your system at here. Alright, so this is your start energy level of reactants, and then you have a certain value, and then it's go down. So you can see from here, this point will be your initial point, initial energy. Right? So above it will be positive, below it will be negative. Right? So in this particular system, you have EA over here. Right? So you have activation energy. So the rest over here will be your enthalpy value. So in this particular example, your enthalpy value is negative. So that is why, okay, so this is your reactant, this is your reactant, this is your reactant, this is your product. So that is why your system have delta H of reactant higher than delta H of product. So again, it reflects to this statement. Alright, so now you want to know about endothermic. So in reflect or opposite from exothermic, we call as endothermic. So if exothermic is releasing heat, endothermic absorbing heat. Alright, and then if exothermic is give negative enthalpy value, so endothermic give you positive enthalpy value. And of course, it means that the product enthalpy is higher than enthalpy of its reactants. So example, you can see from the ice, okay, when ice melts, meaning that the ice absorb heat or the ice give you positive enthalpy value. Okay, it absorbs heat from surrounding into the ice system so that ice can melt. So for example, so now you can see the heat. Alright, so heat is stated at the reactant. Means that it absorbs heat to produce product. Previously, reactants produce product plus produce heat. Alright, so heat will be at product section. But endothermic, you know that endothermic is heat absorbed. Alright, heat being absorbed. So that is why heat must be at the reactant side. So H2O solid, which is your ice, will absorb a certain heat from the surrounding to produce H2O liquid. Alright, or the H2O liquid. Okay, so for example, you have water liquid and then you heat up the liquid. What happens? You can have a gas or steam. So the H2O liquid absorb heat, so that is why heat plus H2O liquid will form H2O gas. Alright, so that is endothermic reaction. So it's just opposite from exothermic reaction. Okay, again, this is the profile for endothermic reaction. So you can see the reactant's energy level will be very low as compared to exothermic. Exothermic in the middle, now is very low. And then you will have a big EA or activation energy, and then your product will be from higher level. Alright, so means that if you can do your proper energy over here profile, so since this will be your starting initial reactants, right? So reactants is over here, so this energy value will be your initial point. Okay, so above it is positive, lower it here, it will be negative value of enthalpy. So now it starts from here, and then you have activation energy, and then you have a product over here. This is your product. From the product enthalpy to the initial enthalpy will be your delta H, the difference of delta H for this overall reaction. So you can see that delta H is positive value. Okay, so that is the profile of endothermic reaction. So again, if you write it down, the profile will be for exothermic reactant, product will be lower. Endothermic reactant, the product will be higher. Okay,